Welcome to Preeminent Test Prep. Today will be day 9 in our SAT preparation series. So today we're going to start with the math section. We'll do that for about a half an hour and then we'll transition over to the reading section. So for the reading section today, we'll be doing another diagnostic test to see whether speed or accuracy is your problem with the reading section. And then as we go on in the lessons, I'll talk about specific tips on that reading section for how to improve your accuracy as well as your speed. But we're going to start with the math section. So today we're going to be doing SAT practice test 4, problems 1 through 8 on the math no calculator section, and then problems 1 through 8 on the math with calculator section. So as I go through, put the work in your workbook, and anything that I say as far as strategy or tips or tricks or setups to look for, put in your notebook. So I'll try to give tips on what to put in the notebook for each question as I go through them. So we're going to go ahead and get started with question 1. So we've got which of the following expressions is equal to 0 for some value of x. All right, well, in order for it to be equal to 0, I see as I look at my expressions, I have absolute values in A through D answers, and then I see I have +1 in answers B, C, and in answer choice D. Well, my absolute value, the minimum that it can be, is 0. So if it has a minimum of 0 and we're adding 1 to it, then that means that the minimum that it can be is 1. So then B through D have a minimum of 1. So they will never equal 0. So I can get rid of B, C, and D. I see I'm left with answer choice A, which works because it has -1, right? So it's going to be a minimum of 0. 0 minus 1 gets us -1. And then if we have 1 in our absolute value, which would be 2 for x, right? So 2 minus 1 is 1. 1 minus 1, that is equal to 0. So we see that just from getting rid of our wrong answer choices, we can see A is correct, and we don't even have to really do anything for A as long as we understand that absolute value means that we can have a minimum at 0. So thing to put in your notes here is going to be that absolute value sign means that you're going to have a minimum of 0. That's really important for the SAT math section, is understanding that absolute value is going to have that minimum at 0. So as long as you understand that, that's really the big tip for number 1. So that should go in your notebook. All right, question 2. If the function above b is a constant, if f of 6 equals 7, what is the value of f of -2? All right, so in order to solve for this, we have to solve for b. So what we're going to do is we're going to plug in that 7, because that's what f of 6 is equal to. And then we're going to do 3 over 2 times 6 plus b, and we're going to solve for b. So we've got 3 over 2, which is 1.5, times 6. That's going to give us 9. So now we have 9 is equal to 7. So we got 9 plus b. We're going to subtract 9 from each side. We see that we are left with 7 minus 9, which is -2, which means that b is going to be that -2. So now that we know that, we plug in our -2 in for x, and we solve for what f of x is. All right, so we're going to have f of x then is going to equal, that x is -2, so I'll go ahead and write that. This should be f of -2 is going to equal 3 over 2 times -2, and then -2, since that b is a -2. So 3 over 2 times -2 is going to give us -3, and then we're going to have -2, which is going to give us -5, right? Because -3 minus 2 is -5. So our answer for number 2 is going to be A. All right, question 3. So anything for notes on number 2, I would say a big thing would just be making sure that we understand that we have to solve for B in this scenario, but you're going to have that in your workbook, and you're probably going to catch on to that as we do more problems. So really no big tips for number 2, no big setups that we can save time on with there, just kind of doing the math on that one. All right, question 3. If xy is the solution to the system of equations above, what is the value of y? All right, so in this situation, this is something you're going to want to put in your notes. Once again, we have stacked equations. Now, in this scenario, we aren't actually going to be adding or subtracting anything, but what we see, and this is a trick that should go in your notes, is that we're given what x equals, and that in order to solve for the value of y, we have to plug that x in up here, because then we get rid of our x and we only have y's, because we'll have a y on top and a y on bottom. So to solve for the value of y, that's going to be our quickest way to do it. So what I want you to put in your notes is that if you're given what one variable equals and you're asked to solve for the other variable, go ahead and substitute in the equation that is equal to the variable that you don't have to solve for in, so that way you have only the variable to solve for. So in this situation, we're going to take this 4y plus 1, so 4 times y plus 1, and that's going to be equal to our x, so we're going to substitute it in up top. We're going to have that much over y is equal to 6. Now we're going to distribute our 4 to our y and our 1, so now we're going to have 4y plus 4 over y is equal to 6. Now we got to multiply each side by y. So now we've got 6y equals 4y plus 4. We subtract 4y from each side to get all of our y's on one side, because we have to isolate y. So 6y minus 4y leaves us with 2y is equal to 4. We divide each side by 2, and we get that y is equal to 4 over 2, which is equal to 2. So we're asked for the value of y. Once again, we want to pay attention to what the end of our question is asking, because sometimes it'll say 2y plus 1 or something like that. But in this case, we're just asked to solve for y, and that's going to be answer choice A, 2. So like I said, things to put in your notes there is just if you're given what one variable equals to and you're asked to solve for the other, just go ahead and substitute that into the equation. So that's the big tip for your notes on that one. All right, question 4. If f of x is equal to negative 2x plus 5, what is f of negative 3x equal to? All right, well, that just means when we have this f of negative 3x, we're substituting that in for whatever x is. So we're going to have f of negative 3x is going to equal negative 2 times negative 3x and then plus 5. So now we just go ahead and multiply our negative 2 by our negative 3x. We do that, and we're going to get 6x plus 5 as our answer. So f of negative 3x is going to equal that 6x plus 5. So we know that that answer choice there is going to be B for number 4. So as far as tips for this one, it's just understanding that if you have f of a certain number, then you're going to plug that in for whatever x is in your equation. So if you didn't know that, make sure to put that in your notes. Other than that, there's no big setups on 4. So far we've had setups on 1 and 3, but not so much on 2 and 4. All right, question 5. Which of the following is equivalent to the expression above? Okay, so this one there's going to be a little bit of a trick that we talked about yesterday, but if you don't have it in from yesterday, make sure you put it in your notes. So what we're going to do here is we're going to take our 2x plus 1, and we're going to start by multiplying it by 4x plus 1. So we're going to start with our first term. So we've got 2x times 4x. That's going to give us 8x squared. Then we have to multiply this 3 by it. So we got 3 times 8x squared, and that's going to give us 24x squared. So I'm going to go ahead and get rid of a then, and I'm going to get rid of d. So now I'm left with b and c, and I see they each have that plus 3, so now I'm only going to worry about my x value. All right, so I have to find the coefficient of x now. I see I'm going to have a plus 4x because 1 times 4x is 4x, and I see that I'm going to have that 2x times that 1, so that's going to give me a plus 2x. So that's going to give me 6x, but I have to multiply that then by my 3. So I multiply that by my 3, and that's going to give me my 18x. So I'll have plus 18x. So I know that B is incorrect, and I know that C will be my answer. So the big thing you want to put in your notes for that one is, did you notice how I didn't consider this 3 since it was the same in both B and C? I just went straight for that 18. So you want to put that in your notes, right? You want to get rid of wrong answer choices as quickly as you can when solving for equivalent expressions. That shows up a lot on the SAT. So you want to make sure you get rid of wrong answer choices as fast as possible and then only work towards things that will help you eliminate the other wrong answer choice. So on finding equivalent expressions, it's a lot about finding what's wrong with the other answer choices to get to what is correct. Because if you have to solve for everything in the correct one, it could take you longer than if you're just solving for what's wrong in the other answer choices. So make sure you have that in your notes if you don't already. Question 6. So right here, which of the following must also be true if a minus b over b is equal to 3 over 7? So what I'm going to do right here is if I ever have a single variable on the top or the bottom and it's equal to a number, I'm just going to go ahead and call that variable that number. So I'm going to say b is equal to 7. So I'm going to take this, make it a 7, and I'm going to take this, make it a 7. Now I can say that a minus 7 is equal to 3. Right? That a minus 7 equals 3. I can go ahead and solve for a now by adding 7 to each side. 7 plus 3 is 10, so now I know that a is 10 and b is 7. So now I can just go through, now that I know what a and b are, and solve for my correct answer. So I'm just going to go ahead and start by looking at a over b. What's a over b equal to? Well, I know my a is 10, and I know my b is 7. Therefore, a over b must equal 10 over 7. I see that a is incorrect then, and I see that b is correct. We have that 10 over 7 is equal to a over b. So I know answer choice 6 is going to be b. So the big tip there is that if we see that we can go ahead and name one variable, right, it's set equal to a constant already. So in this case, b was set equal to 7 already. I'm going to go ahead and call that variable what that number is, right? So I'm going to go ahead and label b7, and I'm going to plug that 7 in then to find my answer faster. So that's the tip there that should go in your notebook. All right, question 7. So we've got a big chunk of text here. So as we go through, we want to make sure that we're underlining units, what variables are, any equations, things like that. So while preparing to run a marathon, Amelia created a training plan in which the distance of her longest run every week increased by a constant amount. Right, so that's a fixed amount that it's increasing by. If her training schedule requires that her longest run in week 4 is a distance of 8 miles, and her longest run in week 16 is a distance of 26 miles, which of the following best describes how the distance Amelia runs changes between week 4 and week 16 of her training schedule? Well, we know it has to increase by a constant amount, so that's going to be our slope, and we see that our time, so our units of weeks, we go from week 4 to week 16, so we got 16 minus 4 there. We know that that's 12 on the bottom. We know that our longest run at week 16 is going to be 26 miles, and our shortest is going to be 8 at week 4. So 26 minus 8 is going to leave us with 18. 18 over 12 can be simplified down into 3 over 2, which is 1.5. So we know that her distance of her longest run will increase by 1.5 miles per week, because we had weeks down here and we had miles up top. So we look at our answer choices. That says A, Amelia increases the distance of her longest run by 1/2 mile each week. That's incorrect. We know it's 1.5. Amelia increases the distance of her longest run by 2 miles each week. We know that's incorrect. She increases the distance of her longest run by 2 miles every 3 weeks. That's incorrect. And D is correct. Amelia increases the distance of her longest run by 1.5 miles each week. So one tip I would have here is if you struggle with word problems and you struggle interpreting them, would be to use units. So if you see what I did here, look at how the answer choices, we got miles each week here, and we have miles each week here, and we have miles every 3 weeks, and then we have miles each week here. So if we see that what we can do then, if we struggle with word problems and setting them up, is we can try to use units to help us, right? So miles each week is the same as miles over weeks. So then what we would do is we'd set up that 26 miles minus 8 miles, get our miles up top, divide it by that 16 weeks minus 4 weeks. So now we would have 18 miles over 4 weeks. And we would see we probably set up our equation right because we have the correct units, right? 3 out of those 4 units are miles each week. So that's one way that units can help you. So if you want to put that in your notes, you can. If you struggle with word problems, it can be helpful to use units. If you ever take a physics class, make sure that you pay attention to units because they're really important there as well. So. All right, question 8. Which of the following equations represents a line that is parallel to the line with equation y equals negative 3x plus 4? Well, we know that lines that are parallel have the same slope, so same slope, equal slopes. We see our slope here is negative 3x. So now, if we look at our equations here, none of them are in slope-intercept form, but we can still solve for the slope fairly easy. I've showed you this in our equations during our first week of practice. What we're going to do is we're going to subtract our x variable. Right, so we're subtract our x variable, and I'll go ahead and do this for a. So I'm going to subtract my x variable, so that's going to give me negative 6x, and then I'm going to divide it by the coefficient in front of my y. So the coefficient is this 2. Now if this were a minus 2y, my coefficient would be negative 2, but since it's plus 2y, that's going to be just a 2. If it were negative 2y, that would be a minus 2. But right here it's just going to be 2, so we know that our slope then is going to be negative 3x, which means that answer choice A will be our answer because it has to be parallel since it has the same slope. So now I don't even have to do B, C, and D. And if you come up with the right answer and it's A, don't check B, C, and D. It'll slow you down. Go ahead and move on to the next question because you don't want to waste time checking answers if you already have the correct answer. So our answer there will be A. So that takes us through 1 through 8 of the math no calculator section. So now we can go ahead and, or I guess I'll give you the tip for this one. So tip for 8 would really just be making sure that you don't waste time going through wrong answer choices. Once you determine the correct answer, just move on. Don't check the other answer choices. So put that in your notes if you're not already doing that. Make sure that you're not checking wrong answer choices after you found the correct answer. Once you found the correct answer, just move on to the next question and save your time. So that would be the tip I'd want you to put in your notebooks there. Also, if you didn't understand this part here, taking that subtraction of the x, so in this case it was 6x, so we subtracted 6x, and then we divided by that coefficient of the y to get the slope, right? So we divided by that 2y, or that 2 to get to our slope of negative 3x. If you didn't understand that, put that in your notes as well, because that's going to be very, very helpful in identifying parallel slopes and perpendicular slopes. So put that in your notes if you haven't already, and we're going to switch to the math with calculator section now. All right, let's get started with the math with calculator section. So we're going to start with number 1, and we'll go through it just like we did with the math no calculator section. So the monthly membership fee for an online television and movie service is $9.80. The cost of viewing television shows online is included in the membership fee, but there is an additional fee of $1.50 to rent each movie online. For 1 month, Jill's membership and movie rental fees were $12.80. How many movies did Jill rent online that month? All right, well, we know that she has an initial cost of $9.80, and we know her total cost is $12.80. And we know that she gets charged an additional $1.50 per movie that she rents each month. So what we'd do here is we'd subtract $9.80 from each side, and we would see that we would have $3 then. $3 is equal to $1.50 per movie. We'd divide each side by 1.5, and we would see that we have M is equal to 2. Right? Now another way that you could do this, so we see our answer there is going to be B. Another way that you can do this, and the way that I would recommend doing this, is if you're in these earlier word problems, so for example about 1 through 10 or 1 through 12 maybe, a lot of times they can be solved in your head without writing out all of the work and taking all that time. So if you're able to do math in your head quickly, then what I would recommend doing is seeing, okay, I have an initial cost of $9.80, a final cost of $12.80. I know it's a difference of $3. I know it cost me $1.50 per movie. I know that $1.50 times 2 movies gets me to $3, so it must have been 2 movies. Now, if your brain doesn't work like that and you're a little bit slower with math, then you're going to want to make sure that you write out all your steps. But if you can do it in your head, go ahead and do it in your head. So don't feel like you have to show out all your work if you can do it in your head like this on the earlier problems. On the later problems, for example, 12 and above, they get more difficult, so it's a lot more helpful to write out your work as you go. But keep in mind, if you're trying to move quickly on these beginning sections, that it can be helpful just to do it in your head. So if you want to put that in your notes, you can. Otherwise, we're just going to move on because there wasn't really any big setups with number 1. All right, number 2. One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Donald can currently type 180 words per minute, and he believes that with practice he can increase his typing speed by 5 words per minute each month. Which of the following represents the number of words per minute that Donald believes he will be able to type n months from now? All right, well, he's typing 180 right now, and we know that it says that he will increase his typing speed by 5 words per minute each month, m. So we know that his equation for his typing speed m months from now must be 180 plus 5m. So that's going to be answer choice C. All right, so as far as tips for number 2, it's really just making sure that you're underlining what I told you to underline in the earlier videos. So that's going to be information containing units of measurement, units of time, rates, so words per minute, that's a rate. We want to pay attention to rates, what any variables mean, so m months from now, and then what the end question is asking. So how much will he be able to type in words per minute m months from now? So just making sure you're paying attention to what's being asked in the question is really the big thing for number 2. All right, number 3, if a 3-pound pizza is sliced in half, so we've got a 3-pound pizza sliced in half, and each half is sliced into thirds, what is the weight in ounces of each of the slices? All right, well, we start with 3-pound pizza. We slice that in half, so we're going to multiply by 1/2, and then each half is then sliced into thirds, so we're going to multiply by 1/3. So we see that we have 1/2 times 1/3, that's going to be 1/6 times 3 pounds, so that's going to be 3 pounds over 1. And now we see that we're going to have 3/6, which is equal to 1/2. So we're going to have 1/2 of a pound, so 1/2. All right, so that's 1 pound over 2. So that's going to be half a pound right there. But we need to convert from pounds to ounces because we're asked for the weight in ounces. Once again, we got to make sure we pay attention to the end question because a lot of times I bet that a 1/2 would show up in our answer choices because that's what it is in pounds. But we're asked for ounces, so we have to take that 1/2 and multiply it. I'll go ahead and show you with units as well. So once again, if you struggle in the math section, one thing that can help you is using your units, especially with word problems. So we have 1 pound we have a 1/2 pound of pizza, right? Per slice, we multiply that then by 16 ounces per 1 pound. And we see that our pounds cancel then, and we're left with 16/2, which is 8. So we have 8 ounces. So our answer there will be C. So once again, the tip there is if you struggle with word problems, you can use units to help you cancel things and make sure you get to the right answer. So that would be the big thing there. Also, if you have a question where it's something like this with pizza, where it's sliced in half and then sliced into thirds, you're going to multiply by that half by that 1/3. So if you don't understand that, make sure you look over this question a little bit more before you move on and then put it in your notes if you need to. All right, question 4. Nick surveyed a random sample of the freshman class of his high school. So this is key. If we remember back to our equations, we talked about random samples. That means that it's good data. To determine whether the fall festival should be held in October or November. Of the 90 students he surveyed, 25.6 preferred October. Based on this information, about how many students in the entire 225-person class would be expected to prefer having the fall festival in October? Well, we know that we have 25.6% prefer it in October, and we know that we have 225 people in his class. All right, so I took this 25.6% and I wrote it as 0.256 because that's what we do with percents when we have to multiply. So now I'm going to plug that into my calculator to solve for how many people would prefer it in October, and I'm going to get 57.6, which I know is about 60. So my answer there is going to be B. So as far as tips for that one, once again, just making sure that we're underlining the key information. So that random sample could have been important. Making sure we're underlining the dates, right? Units of time, November and October. We have 25.6% preferred October, 90 students surveyed, an entire 225-person class, and then paying attention to what we're asked to answer with, so that how many would be expected to prefer the fall festival in October. So with word problems, it's really making sure that you're just identifying the key information in that problem as you go through, so you don't have to read through it twice. All right, so question 5 then. the density of an object is equal to the mass over volume. So we got density is equal to mass over volume. You should also put this in your math equations sheet that you have from your notebook. It's not required knowledge. They'll give it to you on the SAT math section, but I think that it's helpful to know. So I would still put it down there and memorize it. But we've got density equals mass over volume. So what is the volume in milliliters of an object with a mass of 24 grams and a density of 3 grams per milliliter? So we have 3 grams per milliliter, and that has to equal our 24 grams over X amount of milliliters. So one thing that I would recommend doing is instead of multiplying by X and then dividing by 3, just thinking 24 divided by what gives me 3, and then you would probably quickly recognize 24 divided by 8 is going to give me 3. So that would be 8 milliliters is equal to X, right? But if you didn't recognize that, then what you're going to do is you're going to multiply each side by X milliliters, right? Get rid of that, and then divide each side by 3 grams per milliliter, and you're going to end with 24 over 3, which is 8. So I would recommend trying to solve it in your head if you can. When you see that 24 over a number equals 3, just think 24 divided by what equals 3. 24 over 8 is going to give me 3, so I know that B would be my answer there. So once again, the tip for this one would just be put density equals mass over volume in your equations sheet if you haven't. It's not necessarily required, but it can be helpful. And then the other thing is just if you can recognize something in your head on questions 1 through 12, go ahead and do it that way and save time. Because if you can save time, that's going to be pretty important as we get into the later problems, which are much more difficult. So question 6. Last week, Raul worked 11 more hours than Angela. So Raul equal 11 plus whatever Angela worked. So Angela is going to be an A, Raul is going to be an R. So here's a tip for the SAT math section. Make sure that you're labeling your variables basically what the first letter of the word is. So as I read through problems sometimes, I'll go ahead and write out my equation as I read through. Keep in mind I never stop reading through. I just don't look at my pencil and I just keep reading as I write it. So I named Raul R, that's the number of hours he's going to work, and Angela's hours are going to be A. So then I'm asked if they worked a combined total of 59 hours, how many hours did Angela work last week? Well, that's going to equal R plus A, right? R plus A. And we know then that R is equal to 11 plus A. So we'll have 11 plus A plus A. That's going to equal 11 plus 2A. 11 plus 2A. I subtract 11 from each side. That's going to give me 48 is equal to 2A. I divide each side by 2. And I see then that A is going to equal 48 over 2, or 24. So my answer there will be A. So once again, the big tip there. First tip that I had, make sure that you're labeling your variables what the first letter of the word they represent is, because as you get into questions that are like 20 through 30, that's going to be important as you get into inequalities. And then the next tip that I had really is just, there's a lot of questions that are like this where you have a Raul or an Angela and they're set equal to a certain number of hours, and then you have to substitute in. So we know that A was just equal to A, Angela's hours equal to her hours, and Raul was equal to 11 plus A. Just making sure that you understand that if you're talking about how many hours they worked combined, you're going to want to make sure that you're taking this A then, or this R, and setting it equal. So for in this example, we had 59 is equal to R plus A. So making sure that we're getting rid of one of those variables, so either the R or the A, so that we can solve. So in this case, we made sure that we got rid of our R by plugging in 11 plus A, and then adding that A. So we see we got rid of R. So just making sure you're getting rid of one of those variables there. All right, question 7 is right here. Movies with greatest ticket sales in 2012. The table above represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and Motion Picture Association of America, MPAA rating. What proportion of the movies are comedies with a PG-13 rating? Well, I see PG-13s right here, and I see comedies right here, so that's going to be 4 movies out of our total of 50. Now, keep in mind, don't panic if you don't see 4 out of 50 on here. It might not be on there, and in this case it isn't. Just make sure that you then simplify down to 2 over 25, and you see our answer there is A. So the tip I have for this one is when dealing with proportions, don't freak out if your proportion that you get is not in your answer choices. Just look for a way to simplify. So in this case, I saw that 2 goes into 50 because 2 times 25 equals 50. And then I saw that 4 can be split up into 2 times 2, right? So just making sure that you're able to simplify, right? So then we cancel the 2's and we get 2 over 25. So don't panic if your proportion isn't in your answers, just simplify a little bit. All right, question 8. So this one asks about quadrants. So I'm going to go ahead and show you what quadrants are real quick. So quadrants are areas on a graph. So this is going to be quadrant 1, this is going to be quadrant 2, this is going to be quadrant 3, and this is going to be quadrant 4. So put that in your notes section. You can put that in your equations section. That would be a great spot to put it. If not, just put it somewhere else in your notes, and just understand that we start here at 1, and then we are moving counterclockwise around our graph to 2, to 3, and then to 4. All right, so we're going to move that direction. So we're told line L is in the XY plane and it contains points from quadrants 2, 3, and 4, right? So it's like this. This would be an example of what that line could be. But no points are from quadrant 1. Which of the following must be true? Well, if we look at what I just graphed out, and that's another tip, if you're dealing with lines and quadrants, it can be very helpful to graph it out. Don't spend time doing this though, because you don't need to do that for quadrants questions most of the time. So just sketched out quickly like this, 1, 2, 3, 4, say, okay, it goes through 2, 3, and 4. I see that it must be a line that it has a negative slope, right? So the slope of line L must be negative in order for it to go through points or quadrants 2, 3, and 4, but not quadrant 1. So quadrants questions, it's helpful just to go ahead and graph it out real quick and then put your line through based on the criteria that they give you. So we know our slope there has to be negative, so our answer choice will be D. So make sure you put this quadrants part in your notes, and then I would suggest just writing down something about quickly graphing on quadrants questions. So that's going to take us through the math section for today. It looks like we got done a little bit early, but that is okay. We'll switch over to the reading section, and you'll take your diagnostic test there, pair it with your results of your other diagnostic test to see whether pacing is your problem or whether accuracy is your problem. And then I'll go over the answers for that reading section so you can grade it, and then I'll give you tips and tricks as well that you can put in your notebook for the reading section as I go through that as well. So we're going to go ahead and switch over to the reading section now and get started with that. Alright, so today for the reading section, you're going to be doing a diagnostic test just like you did 2 days ago. So 2 days ago you did a social science passage, today you're going to be doing a science passage. So I'm going to give you 13 minutes, and I'm going to make sure I set a stopwatch this time. So it's going to be exactly 13 minutes, which is how much time you'll have per passage on average on the SAT reading section. So your 13 minutes will start, and then I will tell you when that 13 minutes is up, at which point I'll take about 7 minutes and let you just kind of, so basically switch pens. So at 13 minutes, you'll have written down your answer choices as best you could in the 13 minutes with one color pen or pencil, and then you're going to switch colors and then go through and take as much time as you need to find the answer choice that you think is correct. So basically, you're going to take however many minutes you need after that 13 minutes, go back through and switch any answers that you need to in a different color. So keep that old answer so you can at least see if it was correct. And then at about 20 minutes into this, so 50 minutes about into the overall video, I'll go ahead and get into the answers to this passage, and then I will get into why the answers are correct, any tips I have for the reading section, any tricks I have for the reading section, anything you should put in your notebook, my approach to the reading section, things like that. So your 13 minutes starts, or hang on, so this is questions 22 to 31 on SAT Practice Test 1. So SAT Practice Test 1 is going to be linked in the description of this video. So click that link, click SAT Practice Test 1 on College Board's website. It'll open up a PDF, go to the reading section, and then go to questions 22 to 31 to fill this out. All right, so once you do that, I'll give you about 15 seconds to open that up, and then I'll start saying go, basically, for your 13 minutes. So pause the video if you need to. I'm going to say start in about 10 seconds here. All right, 3, 2, 1. You may begin the reading section. Okay, that is 13 minutes, so go ahead and make sure that you have all your answers down for this passage, and then switch to a different color pen or from a pencil to a pen, so that way you can see your different answers after you have more time. So I'll give you about 7 minutes before I start going into the answers and the answer explanations, tips, tricks, and strategies. If you need more time than that to be certain of your answers, then take more time and then come back after you pause the video and then watch the answers, why they're correct. I'll explain why, as well as tips, tricks, and strategies to put in your notebook. So go ahead and take about the next 7 minutes or however long you need, and then I'll start teaching again in 7 minutes. Alright, so if you need more time, make sure to pause the video and go ahead and take some more time to get your answers finalized. If not, and you're ready to go ahead and grade and go through our answer explanations, tips, tricks, patterns, everything for the SAT reading section, then we're going to go ahead and get started with the answers. So we got question 22 is what we're going to start with. The authors use the word backbone in lines 3 and 39 to indicate that. Well, let's go to lines 3 and 39 and see what it's indicating. We got the molecule is a very long chain. I'm going to use a highlighter here. The molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate groups. Okay, so this backbone is going to be a chain of sugar phosphate groups. That's very long. And then in line 39, we've got the sentence is going to start up here. If this is true, these conditions for forming, I'm sorry, it's down here, 39. The phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of the base can fit into this structure. Okay, so it's a phosphate backbone, a phosphate sugar backbone. It's got repeating structures along it. So we look at our answer choices. We see we have A, only very long chains of DNA can be taken from an organism with a spinal column. We don't talk about that. We can get rid of A. We don't talk about spinal columns in particular. B, the main structure of a chain in a DNA molecule is composed of repeating units. Yes, that is true, right? We talked about how it is repeating units of sugar and phosphates. So we know that our answer is going to be B for question number 22 because we have a repeating sugar phosphate backbone. We talked about that in lines 3. And also in 39, we talk about the backbone. A chain in DNA molecule consists entirely of phosphate groups or of sugars. No, it contains both. And then D, nitrogenous bases from the main structural unit of DNA. Nitrogenous bases aren't the backbone. They're in between. All right, so now we got 23. A student claims that nitrogenous base pairs randomly with one another. So it's claiming that those pairs go randomly with one another, which the following statements contradicts the student's claim. All right, well, we know in the passage it talked about how we have predictability. They're not random with one another. We have one purine with one pyrimidine. In particular, we have an adenine with a thymine and a guanine with a cytosine. So just looking at my lines real quick, I know that that was too early in the passage to have been my answer. So I'm really looking at 23 to 25 and then 27 to 29. So I'll go back and check that. We've got 23 to 25 is our first one. So that would be right here. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a single base from another. That doesn't talk about it not being random, so I move on to my next lines, which were 27 to 29, I believe. One member of a pair must be a purine, the other a pyrimidine in order to bridge these two chains. So that shows how it's not random because one is going to be a pyrimidine and one is going to be a purine. Therefore, it cannot be random. So that's going to be in lines 27 to 29, I believe. Yep. So we got answer choice D for number 23. Answer choice D is correct. All right, next up we have question 24. In the second paragraph, lines 12 through 9, what do the authors claim to be a feature of biological interest? All right, well, let's go back to our lines because we always want to use the lines when it directs us to them. The first feature of our structure, which is of biological interest, is that it consists not of one chain but of two. So that was really easy because our question was, what is the biological interest? And that is that it consists of two chains, right? Not one chain, but two chains. Two chains, kind of like the rapper, yeah, funny joke for you there. Okay. So we go down here, we see that we've got second paragraph, what do they claim to be a biological feature of interest? And that's going to be D, DNA consisting of two chains, as I pointed out right there. So you can get rid of A, B, and C because they are going to be incorrect because it was very obviously DNA consisting of two chains. All right, question 25. The author's main purpose of including the information about X-ray evidence and density is to what? Well, let's go back up and let's find where we talk about X-ray evidence and density. I remember that that's back right around here in the beginning. So we have, however, the density taken with the X-ray evidence suggests very strongly that there are two. Well, two what? We have to go back and get some context. I'm assuming it's going to be two chains, and I see that it is because we talk about it was assumed before there was only one chain. However, density with X-ray evidence suggests that there are two chains. Once again, two chains like the rapper. Funny joke for you there. All right. So author's main purpose of including the X-ray evidence and density is to show that there is two chains. Let's find our answer that says that. We have A, establish DNA as the molecule that carries genetic information. No. B, present an alternate hypothesis about the composition of a nucleotide. No, those nucleotides are those things that are in between those backbones. C, provide support for the author's claim about the number of chains in a molecule of DNA. That's correct, right? That supported that two-chain model. So our answer there is going to be C. D, confirm the relationship between the density of DNA and the known chemical formula. No, we don't touch on the chemical formula of DNA. So we are good with C for our answer on 25. All right, next up, we've got question 26. Based on the passage, the author's statement, if a pair consisted of two purines, for example, there would not be room for it. Lines 29 to 30 implies that a pair, and then we have right here implies that a pair what? Well, if there are two purines, there would not be room for it. That's going to imply that if we have two purines, that it's going to be too big, right? It's not going to fit. So we have a pair of purines would be larger than the space between a sugar and a phosphate group? No, because these occur in between the backbones. So those backbones include that sugar phosphate group, but we're talking about in between them. So we can get rid of A. B, a pair of purines would be larger than a pair consisting of a purine and a pyrimidine. That is true, right? We talk about if there were two purines, it says, there would not be room for it, therefore it would be too large. So that pair of purines would be larger than that of a purine and a pyrimidine. Because that purine and a pyrimidine, they fit. But our pair of purines is too large, it says, in that lines 29 to 30. So we know that B will be our answer for 26. All right, question 27. The author's use of the words exact, specific, and complement in lines 47 to 49 in the final paragraph functions mainly to do what? Well, let's go revisit those lines because when we're directed to the lines, we want to do so. All right, so we're looking at the words specific, exact, and there is one other one that I'll recognize as I read. So we've got if the actual, I think it was actual, the actual order of the bases of one of the pairs of chains were given, one could write down the exact order of the bases on the other one because of the specific pairing. So that's really showing that on one chain, we can know the exact on the other because they pair so specifically. So it's really showing that they're complements of one another, the two chains are. So let's look at our answer choices. We've got confirm the nucleotide sequences are known for most molecules of DNA. I do not believe that that is the correct answer. That does not fit what we were talking about when we read that. B, counter the claim that the sequences of bases along a chain can occur in any order. That would be, that's not really the purpose of what we just talked about. Does it counter the claim that the sequences of bases along a chain can occur in any order? It does not, because the sequences along one chain can, right? We have two chains. The sequence along one chain, it can occur in any order, but we're talking about the sequences between the chains, right? So we have an A paired with a T, a G paired with a C, so it does not do B. So B is incorrect for that reason. C, support the claim that the phosphate sugar backbone of the author's model is completely regular. No, we're not talking about the regularity of it at that point. We're talking about the specific pairing between our two strands, right? We have a G with a C, a guanine with a cytosine, and an adenine with a thymine. So we're really talking about the pairing between those two chains. So D, emphasize how one chain of DNA may serve as a template to be copied during replication of DNA. Yes, right? That's talking about that pairing up, right? How if we have one strand, we know that it's G, and we know the next one's C, and the next one's A. We can say that on our other strand, we'll have C, a G, and then a T, right? So our answer there is going to be D. All right, question 28. Based on the table and passage, which choice gives the correct percentages of the purines in yeast DNA? Well, what are the purines? Let's go back and look at our passage. Our passage told us in the first few lines that two of the possible bases, adenine and guanine, are purines. So let's go find their percentages in yeast based on this table. So we've got yeast right here. We're looking for the percentages of our purines, which we said are adenine and guanine, right? I'll highlight that over here and highlight it over here, adenine and guanine. So we're going to have 31.3 and 18.7. That'll be our answer for this one. So 31.3 and 18.7. 31.3 and 18.7. That's going to be answer choice C for 28. So we know that 28, our answer will be C. All right, moving on to question 29. We've got 29. Do the data in the table support the author's proposed pairing of bases in DNA? All right, well, let's go take a look at it real quick. So if we're looking at the author's, his claim about the DNA pairing, it's that adenine is going to pair with thymine and guanine is going to pair with cytosine. So there should be about equivalent amounts in each of these categories, right? So maize, it should have about an equal amount of guanine as cytosine, which it does. Same with octopus, same with chicken, same with rat, same with all of these animals. We see that those match up. We see that our use blue for this one. We see our adenines and our thymines match up 33, 31, 28, 28.4, 28.4, 28.6. All right, so we see all that. We see they all match up. So yes, it does support it. So that table is going to support it. And we have to explain why as well, right? So does the data in the table support the author's proposed pairing of bases in DNA? So we're going to have to support our answer here. So we've got A, yes it does. We know that it does because we just took a look at the graph, so we can get rid of C and D. Next, because for each given organism, the percentage of adenine is closest to the percentage of thymine and the percentage of guanine is closest to the percentage of cytosine, yes. Right, we have our G's pairing with our C's and we have our A's pairing with our T's, just like it did in that table there. So we know that A will be our answer for 29. Now we can move on to question 30. According to the table, which of the following pairs of base percentages in sea urchin DNA provides evidence in support of the answer to the previous question? All right, so in our previous question, we talked about how adenine was bonding with that thymine and that guanine was bonding with that cytosine, right? And how that supported that those two are complementary strands and that we have a two-stranded DNA. So what provides the best support to our previous question? So we've got two percentages, and we need to find which base pairs are the percentages we want. So we're looking for a guanine with a cytosine or an adenine with a thymine for sea urchins. So I'm going to find sea urchins. I'll use blue again, since we haven't used blue down here. We got sea urchins right here. So I would be looking for a 32.8 and a 17. A 32.8 and a 32.1, or a 17.7 and a 17.3. So either way, two numbers very, very close to each other is what we're looking for our answer down here. I see that the only answer choices that are close together are going to be A. So I know my answer for 30 is going to be answer choice A. All right, so moving on to question 31. Based on the table, is the percentage of adenine in each organism's DNA the same, or does it vary, and which statement made by the author is most consistent with that data? All right, well, let's go look at our table for adenine just to double check, even though we can kind of remember that it's different as we look through it. So we got adenine, we got a 26, a 33, 28, 29, 32, 27, 31, and then a 24%. So we see it does vary. Next up, we can go ahead and go down here. Let's get rid of the ones that say it's the same. We get rid of A and B. We're left with it varies and then two lines. So I would say, just looking at these, I remember later on in the passage we talked about how it varies. So that's lines 41 to 45. So I'm going to go there first, because I remember in this right side, which was started about 40, is when we kind of started talking about that. That was way too far that I zoomed up. Right here. Okay. So 41 through 45 is what it said. So we got, it follows that in a long molecule, many different permutations, which if you don't know what permutations means, I would assume it means possibilities, right? Possibilities. So there are many different possibilities that are possible, or yeah, that works. Many different permutations are possible, so many different arrangements. And it therefore seems likely that the precise sequence of bases is the code which carries the genetic information, right? So it's saying that that gene code is going to be different for each one. There's going to be variance there. So that would be perfect evidence for our statement. So 31 then must be D. It varies, and then lines 41 through 45. All right, so that's going to take us through today's reading section. So make sure you write down how many you got right when you did not have extra time, so during that first 13 minutes, and then write down how much you got right with that extra time. So if you got the same amount right with both times, then pacing isn't your problem and accuracy is your problem. But if you got a lot more right when you had more time, you know that you need to work on getting faster. So you should be able to kind of see a pattern between your days, your test from 2 days ago and this one. So if you struggled with pacing on both of them, you know pacing is going to be your problem. And if you were accurate in your first 13 minutes on both of them, if you were totally accurate in the first 13 minutes, then you know that pacing isn't going to be your issue. So you should at this point be able to see whether accuracy or pacing is your issue at this point. If your two diagnostic tests for reading contradict each other, then go ahead and take a third one of these on your own. I'm not going to give another day for it, but if they contradict each other, I would recommend doing a third one and then taking 2 out of the 3. So if 2 out of the 3 you struggle with pacing, then pacing is going to be your problem, and if 2 out of 3 you struggle with accuracy, accuracy will be your problem. Either way, whatever your problem is, we're going to address both sides of it. So you're going to get better with accuracy if you struggle with it, and you're going to get better with pacing if you struggle with it. And if you're even difficulty in both, you're still going to get better with both of them. It's because I'm going to teach both problems throughout the course. So don't worry too much about it if you struggled today. I'll be giving a lot more reading tips and things as we go through the next couple weeks. So just make sure to stay tuned. As always, there will be a donation link in the description when the donation link is up and running. Thanks for watching. Make sure to like, share, and subscribe. Stay tuned for tomorrow, and have a good day.